Now, good morning, good afternoon, everyone. I hope everyone is well and welcome. Welcome again. Today we are going to work on CockroachDB like usual. As usual also, the issue or PR numbers that we're going to work on are pasted at the bottom of the screen. I'm going to make this font slightly larger. And they are really, the main topic of conversation is in the last of these numbers and corresponds to this PR here. We are going to improve the CockroachDB health probe. I'm going to explain why this is necessary and what we're going to do in a second, but if you already have your browser open, you can go and navigate here and read the discussion a little bit to get some details or preview. But before we get there, we are also going to do a little bit of the daily work, which is to wrap up work that is supposed to have completed already. And so what we have today is a pair of PRs, pull requests. One is something we have worked on this stream already 3-4 months ago, and it had created a lot of associated works that we went through multiple stream sessions over. And now this PR is nearly ready for adoption, but there is a bug remaining whereby the continuous integration is failing, and that needs to be fixed. So today we are going to briefly check what happened here and then improve this and ensure that the PR is ready for accepting by the reviewers. The other PR we're going to briefly look at is a small feature of PR corresponding to the logging effort we worked on before. This is a relatively trivial improvement where the event where TLS certificate rotation events are logged as a structured event. The PR was ready and its CI was ready, and then it got approved by review. But then at the moment where it was supposed to get merged, the build failed. And so that is a common occurrence that can be caused by multiple things, and we're going to investigate that a little bit. And that is not going to take us very long. And then once we're done, which is probably going to take like maybe 5 to 10 minutes, we will go on to work on this main topic for today. I do want to report also that we were working on a different PR last week corresponding to authentication in CockroachDB. So there is no PR filed in GitHub yet. There is a branch on my computer. It has to do something with ensuring that folk can log into unavailable clusters. That is also important, although the design we started to take last week, it needs to be discussed with other people, and that discussion hasn't happened yet. And so I didn't feel ready to resume that work today. And so instead, we're going to work on this, which has a more clear-cut consensus already. And then the authentication question, which is still important as well, will be a topic for probably next time. So here we are. So here are the 3 PRs, and we're going to start with this one because the review is already in, the CI is already succeeded. We just have a failure at the time where it got merged. And so that is a situation which we often have to deal with CockroachDB. And so before I look into this, I'm going to enumerate what I'm going to expect. So there is one legitimate situation in a distributed setting for development is when the PR after it's merged causes a failure because of a merge skew. So in short, what we're talking about here is some other person in the development team made a change concurrent with this one that is incompatible with it. And therefore, we are expecting, if that was the case, a failure that would tell us what the incompatibility is about. Why this would not be caught by the CI on this PR is because the CI on GitHub is running on the code of the PR itself, and that is a branch that we worked on that was taken from the CockroachDB code as of some time in the past. And so it's possible that since the point at which this branch was created, there was no other changes in the master branch that are compatible with this one now. And so maybe the CI is going to tell us this. That's one possibility. Another possibility is a test flake. So we have a couple of unit tests that fail because of some random errors, either in some tests that are unrelated to this work or in the test infrastructure. If that is the case, sometimes just retrying the job is sufficient. Sometimes it is important to skip a test that is failing and let the team that manages that test fix a test. And sometimes maybe some more investigation is needed. Maybe the change that we made here is triggering instability in some other place in the infrastructure that wasn't triggered before. So it's like a box of chocolates. We don't know yet what's going to happen when I click on this tab at the top here. So let's see. So the CI has failed. And we see that there were multiple test targets and only one of them failed. And if I look here, I see no test failure. That means that we're not looking directly at the merge queue that would cause a test to fail because of some incompatibility. So now we don't know which of the dependencies it is, so that's why we click on the dependencies tab here, and that will tell us what failed. So the lint target succeeded, test, roach test, test trace. So all this is basically the main testing targets. And then something failed, and we don't know yet what it is. So let's see. Failed to start. I don't see anything red here. So what failed really? Chain. Oh, here we are. So all this succeeded, but essential CI failed. Interesting. 16306, this one, it says failed 1. Doesn't tell us which one failed. Well, this does tell us this is this one, but it doesn't tell us, doesn't give us a log of the failure. Not here. Okay, let's look at the build log. Snapshot dependency essential CI failed. But the essential CI is an empty target. It only has dependencies, and therefore as soon as all its dependencies have been satisfied, which is the case here, that means that the CI build as a whole should have succeeded. And I don't see any red in the test categories. Just a red here. And it doesn't tell me what went red. So that is a case of a flake in the infrastructure. So even here, it's not our test infrastructure, it's the TeamCity environment that is giving us something strange. And so we are going to report this failure as an issue for investigation by our development infrastructure team. So we are going to call this PR merge. So TeamCity PR's merge failed because of failure in CI, but with all dependencies green. Observed in, and now we're going to paste the link to this. All the CI dependencies are satisfied. Green everywhere. However, the connecting dependency, essential CI, is red. And caused the entire build to fail. This is surprising because essential does not have rules of its own. So there is literally nothing that I know of that it can fail on. So what caused this failure? and prevented the entire CR run from succeeded. There we go. That is going to be here, testing, and probably build system. There we go. And then there is a project. And then we're going to say CC for triage. Off we go. So, infrastructure flake, because of this, I am going to simply reattempt to merge this PR and see what that gives. And we'll see. All right, so that was the first one. And now we're going to go to this one. So this is the PRs that we worked on in the past. The code is ready, the review is ongoing, but there is a failure in CI here. So what happened here is that last week, at the end of last week, probably Friday, I pushed a change to the branch to add a unit test that was missing on this PR before. And the unit test runs fine and it succeeds, and then I push a change. But what I didn't run on my branch was the linter. And so what I suspect, I don't know that yet, is that this CI is failing because the code style is not adequate according to the linters. That's what I'm expecting. It's also possible that there is a legitimate bug somewhere and that will need to be investigated, but we are expecting a linter failure here. So what's going on? All right, it was not a linter. It was an error in this logic test CCL branch, and we are seeing here something related to probably an error, but it doesn't really tell what. Oh, there is a difference between what is expected and what was found. What is the difference here? I don't know, but we are going to find out. Oh, the TTL seconds maybe are not right. Yeah, we don't see the same ordering. Oh, yeah, that's it. Yes, that's it. So you see here, this test here is expecting the partition numbers going incrementally from P1 to P4. And instead, the data was reported P3, P4, P1, P2. So that is because the partition definitions are likely stored in a Go map, and the Go map doesn't give a guarantee of ordering. So this is a straightforward test design error in an area that is completely unrelated to the one we're working on. So when this happens, I could say, well, I'm just going to wait until that gets fixed. But we're going to actually investigate whether this has fixed already. If it hasn't, we're going to file an issue to report the test is failing, and then investigate quickly what needs to be done about it. And then if it's simple, we're going to fix it. If it's not simple, we just let someone else fix it. And then once that other related issue is fixed, we can rebase this PR later on. So let's investigate this. Well, first of all, is this issue reproducing in the latest version of the code? So we're going to log what happened on this package. And we see here, so the latest test was on October 22. That doesn't seem right. So this is really a test that has started to flake recently. So that's not great, but we know how to fix this probably. So let's see if someone else has already reported the problem by filing an issue related to this test. Oh my. Okay. So, apparently not. Oh, no, this file is somewhere else, I think. Logic test. Oh. Maybe it is there. Oh, it is there. Okay, we will come back to this in a little time. All right. So we are going to file the issue still. Bug. And that is in logic test flake in say zone config tests due to non-determinism in show create found in here. Yeah, probably we want these log lines. I start to could argue here there is an improvement. Okay. I'm going to paste this up. Oh, it is already here. Expected. Found. Copying this. Observe, say partition numbers are partitions are reported in a different order. This suggests that the output of show create is non-deterministic when there are partitions. And we don't know where who is implementing this kind of code. So we see here there is some testing related to this. But what would be interesting is to check who is which part of the code is printing out the this one here. What is part of the code is responsible for printing out the create statement? Ah, that is interesting because it is not here. We'll see. Actually, we are going to check who is writing code in that area. And Radu. And who else is doing partitioning? Oliver. Testing. It's going to be, say, we have a multi-region effort. All right. So that's the issue. And so we are going to copy paste this report here. Okay. And we are going to briefly check whether we are able to fix this, because it's possible that the fix itself is not super complicated. And so if it is sufficiently easy, we can probably do it ourselves, and then it will be here we are. It's a it's a zone configuration. We are configure zone. Let's see. Okay, show zone config. This one. All right. Mm-hmm. Before we go there, we really have to look at the test that is failing. So that was on line 1102. So show create actually. Oh, interesting. So show create is reporting zone configurations at the end. Oh, that is new information to me. Let's see. Show create table. Show create interleave. Show create partitioning. Show create locality. Oh. Show create partitioning. Show create interleave. Is there a zone something here? No, there isn't. Show create table. It is here. Show create table. Then we have constraints, but we have alter partition. Why do we have an alter partition here? Non-primary indices. Oh, these are indices. All right. Index for display. Interesting. All indices. Public non-primary indices. These are canonical order, so there is an ordering already. And then we have the interleave. So create partitioning. And here, get locality config, no. Partition. So partition thing is probably fine. And then we have partition values. Zone, also not. All right, so in fact, we don't really know where this is happening. So I personally don't feel empowered to fix this. So unfortunately, this is a bug we don't know how to fix. Cool. So that issue is going to remain there. We are going to make an attempt at rebasing this PR on top of the latest master branch, because maybe the master branch has fixed this already and I don't know about it. So what does the master branch say? Doesn't look like there were really changes about this. I mean, oh, okay. There we go. In fact, this is from yesterday. Yes, so assumedly, yep, that is what it is. Okay. Never mind. Fixed by that is the happy case. You rebase and then there is a fix. Off we go. Cool. All right, so I have nothing else to do. Then repushing the branch after the rebase. And hopefully the CI will be happier. So how to trigger a manual rebuild from CI? Click on the 3 dots here. Wait for this form to load, and it's taking ages because density is misdesigned and it's actually trying to load all the possible PRs from the history of CockroachDB in memory. And given there are tens of thousands of those, it's a bit long. All right, here you go. And run build, and we will hope for improvement from this. Cool. So those two PRs are now in the pipeline, and it's going to be better probably. So this one I can close probably as well. Yep, closed. All right. This one is in the pipeline for getting merged. And now we can work on the piece of resistance for this meal. Cool. All right, so a little bit of context. Integration of CockroachDB in especially a cluster with automation, like someone who is a system administrator and wants to integrate CockroachDB in their infrastructure fully automated, will want to be able to detect when a node is misbehaving. And so we have two probes that we recommend people to use. One is the health probe, which is over the HTTP endpoint, and one is a SQL probe, where we say to people, well, connect to your SQL, a SQL client to the SQL port of CockroachDB to verify that the port is available and that the session can be established, and then send a simple query over that connection as a health probe. And if that returns, then you're probably good. At least if there were major problems in CockroachDB and that would fail, then at least you would know that the node is not ready to be used. So that works and people do this. But what we have learned is that a node can appear to serve local traffic fine and appear to be ready to accept client connections, but is actually not available as a node in the cluster, in the sense that it might be currently disconnected from other nodes in the cluster, or maybe there is a system table that is currently unavailable because some branch is broken or something similar, whereby a simple query or a simple implementation of the health probe would make it appear as if the node was fine, but in fact, with an additional check, it is not fine. So there was a discussion 2-3 weeks ago to improve our existing HTTP probe to add more checks. And this PR was issued as a draft PR to add some additional SQL validation inside the endpoint for the health probe. And we can do this. And the PR was discussed, and there was a little bit of analysis and so on. But then this person said, we have a problem that, well, actually this person said it to me, but personally, but maybe didn't write it down. So Andrew explained, we have an issue, of course, of loads, that is that if we do significant work with a query, for example, accessing system tables or whatever, and we do this as part of the health endpoint, which is freely available to a script, for example, we are opening the door to a denial of service attack. Someone who could by accident or maliciously request an update from the health endpoint at a very high frequency and thereby incur a high load on the cluster by sending queries as part of the health probe. And that means that the simple approach that was taken in this PR is not adequate. It is too dangerous, if you will. And so what we have instead is a discussion here to have a SQL check done periodically in the background of every node, maybe every 5 seconds, stores the result of the latest check, and then reports a copy of this result during the health probe. So that means that if the health probe is issued more often than every 5 seconds, it will always retrieve the same result until it gets updated again. And so that's what has been perceived to be useful, and the advantage of doing so is that it gives us an additional mechanism to inspect the health of clusters internally, and that is really creating a health report. And we can imagine in the future that such a health report could contain a lot of different variables about the current status of a node. And especially things like green or red, like good or bad situations. That would be more clear-cut in terms of what is wrong than just the analog or continuous values that the graphs in the web UI are reporting. So that is the vision. But of course, we want something to make some improvement locally before we implement the grand vision, and so there is a possibility to prototype this health report with just a very small subset of everything we can do, just to demonstrate the overall structure we can give to this mechanism. And so what we are going to investigate today, and we have limited time for doing so, so we are going to time box this properly. So let's see what the calendar gives us. All right, so we have approximately 2 hours, a little bit more, but not much, to see how far we can get. And so we are going to close those files. Yes. Yes, and then create a to-do file. So it's going to be help. All right. So health probe or report. We want to have a background health checker process running periodically. We want to store the results of the latest health check in RAM and make it the health report available via a debug endpoint, and then possibly return a copy of the health report as part of the get payload response for health. Oh, health actually doesn't matter. So that's more or less the plan, and then we can see how far we get with this. Sorry, a little bit of dry mouth. The music in the background is from the Minecraft beta album from C418. Absolutely stunning soundtrack. And a couple of these numbers are musically also quite interesting. I highly recommend it. Anyway, so where do we put such a background check? We have a couple of those already for profiling. And so we have a model to follow. So there is this heap, a start sample environment. This is a check for the operating system environment. And it starts here. And then we have the time series recorder. I didn't know we had a graphite exporter, but that's great. And then there are other things happening. And so we are going to start a background checker. And we are going to do this with a new file. And then we are going to have a health checker. And it has a server, which gives us access to the other subsystems in the CockroachDB node. And probably a stopper, which gives us access to creating background tasks. And then we are going to have a start. Start function. And we need to connect this to the server. And it's going to be here. Probably will be more fields later, but we are going to start here. And we need to define the health checker field here. All right. And we're going to also check whether other tests or things create a server. That seems to be the case. Maybe? No, that's somewhere else. Maybe find the referrers to this type. Let's see what it says. All right. Many references. But it's not so messy, actually. Everything is going through other places to create an instance of here. So we can assume that we have only one place where this needs to be initialized. Okay, that's great, actually. That's good design. Cool. Now, there is a moment where the server needs to be started. And so where does that happen? New server. We merely start a various store pool, make servers. All this here, it doesn't really start any background activity yet. It's just connecting things together, which is great. And then there must be a start method somewhere. Of initial start and server start and a pre-start. And then we have monitoring of clock jumps. And that will create something. Okay. Yeah, cool. Set local internal server. And then configuration. Make server. Workers. Yeah, we will have a worker here, so that's what we want. Okay. Cool. And then something we will have here, absolutely, is the latest health report. So what is a health report? We will need to have a status server. We want to have a public data structure. Probably status. Status. Oh, there is a health check already. Ooh. Interesting. There's something called a health check. Oh my gosh, it already exists. And it emits alerts. That is cool. Interesting. Okay. So that's exciting. That means that there is already some infrastructure here. So let's see where this is called. Recorder. It's here. Symmetrics recorder. It's not the place it should be. Tracked metrics. What is tracked metrics? Oh, it's from the health check thing. Uh-huh. Well, this makes me happy. So there is already infrastructure. So we do not, in fact, need additional infrastructure. Okay, so we need to do some reverse analysis of how this what feature this is. So instead of going blind, reading the code and trying to hope for something, what is worthwhile doing in this case is to investigate when this code came to be. Okay, so it really is. Let's start at the very beginning. This facility was created in 2018. Health check and distress gossip. While generating no status summaries, check for metrics that indicate a severe store node or cluster level problem. Metrics can either cluster gauges, and for the former, we have to keep states that we can notify only with the counter increments. Flag metrics are gossiped under a newly introduced key. These infos are in turn picked up by the newly introduced internal gossip alerts table. I can see that. Monitors CRDB internal gossip alerts table on any node. Plums these warnings to UI. Check our CRDB internal. And we'll see about that. All right. All right. So this facility has existed for a long while, but it's not actually being used. And probably, so it's kind of funny because the person who wrote this, 2018, and I checked together the need for this issue last week. And that person did, in fact, not remember about this probably and did not tell me about this. You see the pull request number is in the low 20s. It's like it's been a while, let's put it this way. So that is very good news. So this means that we are in fact going to extend this mechanism with some additional checks, in particular SQL checks and perhaps other things. And we need to store the result of the latest alerts And that seems to be the case with gossip. So there's a health alert, that's great. And where is this stored? Alerts is alerts. Return, so there is a, must be a check health called somewhere. It's called from a test and from this here. Okay. Write node status. All right, so just called from here. And then it writes the alerts into gossip. Okay. All right, we're going to work upon this a little bit. Cool. That being said, I do need a brief bathroom break. So if you excuse me, I will be back in about 5 minutes. And we are back. Cool. All right, so the way this works is that we have a periodic invocation of write node status, I think. Yeah, it's just above here on a periodic basis at this frequency. And the frequency is passed here. And it's at the default metric sample interval, which I happen to know is equal to 10 seconds. And this will do it the first one at the very beginning. And then periodically we'll call a task to write the summary into gossip. And also here, meaning it also goes to KV. All right, so we have here a situation. We want a health check that is happening in the background, that is memory only. And the facility here is connected to the KV store, meaning that if the KV store isn't available, this entire mechanic here is going to stall and stop functioning. What we really want is to have the health check happen in the background, provide a health report, and then connect that health report to the background status writer using either a channel or some kind of global variable. Because if this gets stalled, we still want the health to get updated. So we have here this health checker recorder is a metrics recorder, and this inherits health checker. Yeah, so that really won't do. We don't really want to have this health checker merely directly store its value in KV. We want to store them locally. So what we're going to do is rename this facility. So that's going to be our first mission. This health check here is actually a bit of a misnomer. And it shouldn't be the entity responsible for computing the gossip alerts directly, I think. Health alert metrics. Okay, so I like this actually. So the category is metrics. So the idea of having health alerts return here is actually pretty good. So node status is fine. And then it does mu update health checker. Update, it will go through all the metrics and verify this. All right, so we are going to keep this. And we're just going to extend. I could use my editor's search and replace function, but in this particular case, I am purposefully doing it manually to force myself to read through the code and learn a bit more about it. Using search and replace makes it a bit too implicit. All right. All right. And then this is a metrics health checker. And then metrics health checker here. And then we're fine. Okay, so the mechanism to connect the metrics health checker to other thing seems to be fine. The mechanism that we're not happy with is the mechanism that calls this loop write node status that is checking the health here makes no sense to me. And then what's going on here with this loop here. What is it really trying to achieve? So let's rename this since. All right, and was there maybe a? Yeah, there was a test file. And now here I can do search replace because test code has less to learn from, I think. Okay, well, that was it. Cool. All right. So what is it doing here? So it iterates over all the nodes to count them. Okay. Then if there is more than one node, it will report on the health. And then it will ask for the current node's ID. What is his health alert key? With the result that is coming from here. So we have a health check result. And then it adds it to gossip. That's great. So that is writing the alerts to gossip. Okay. And then it also writes the status. And the status is a separate variable. It's the generate node status. So this functionality to write the status after generating it here, and that is completely independent from the health check. It's about the current operating system parameters, and then writing it to KV. That's fine, but it's not related to this thing here. And that functionality here, we don't want to interleave this with a mechanism that can stall on KV accesses. More to the point, this is contingent on start write node status here, looping here and having this function return. And if it doesn't, then, well, we simply don't get updates anymore. So it was more or less a mistake to integrate the two mechanisms in this way. And so we are going to decouple them from each other. All right. What we do want, however, is to get a copy of the health report in the node status, the latest copy. So we are going to look at this. So that is not done. That's not done. And then integrate copy of the health report inside the node status. Cool. All right. And then this is in status PB. So we have alerts. with some category. Fine. Where is the category network being used? Alert. It's not being used today. That is kind of a bummer. Ah! This was over-designed. It was actually not finished. Probably. When it was created. It's okay. Have health alerts. I don't have a double here. That is odd. It's okay actually. We can store a boolean in a double, just value 0 or 1. And then we're going to call this a health report. I don't want to call it a report. Reports suggest there are many of them. A health. Line is a indicator about the health of one subsystem. Lines reports has been checked unconditionally. Lines that correspond to unwanted and desired conditions are also translated into health alerts. And then we can do those things. It's the same type, in fact. It is in fact the same type. Value indicates can be set to the value 0, 1 for to report Boolean conditions. And then here we have more things. So the metrics we are likely going to extend as well. Maybe we are going to call that enum here. So service is not clear. So we will see what we check, but the basic things we want to check are in fact, we probably want more things here. Yeah, server. Yeah, service. So times service. Component subsystems, right? All right. All right. All right. All right. So now we have health lines alongside health alerts. And the node status, eventually we'll probably get a copy of this at some point in the future. We'll see. Now, we have our metrics health check file. And that returns a health check. Results, and we are probably going to merge them. Is that something we want? We probably want to indicate this in, say, type. If we have two subsystems reporting different things, yeah, we're just going to concatenate them together. That's probably going to be fine. All right. Store ID, store ID. Pages, metrics map. Cool. So we are going to report the current values over here. So lines. All right. Ifs. Where is this function used? Matrix map. Oh. Tracked metrics return less in value. Only non-zero values are reported, and the seen non-relative values are persisted for the next call. All right. Okay. Prev. Where is the prev? Where is D? D's metrics map. Okay. Oh, look at this. All right, so the diff is returned, but the current value is in metrics map. D stores val. And if the val is more than the threshold. All right. Oh, the gauges are not stored. Why not? There could be. There could be. We are going to store the current value of symmetric and condition in D, we do so even for gauges? So that the health checker can report health minus, right? And so the line's already here. Alerts. Alerts. Okay. When for values that parametric settings. Seed zero threshold. Report lines for all known metrics. And copy paste. Seems fine. Cool. All right. All right. All right. All right. That is an extension to the metrics health check, and now we are able to get a full health report, health check result. Verify that this test is probably running. Yeah. Let's build the protobuf. Mm-hmm. Yeah, so now we have a different situation, which is that the metrics is health category now. Health category. Cool. Cool. And we said that we wanted to check that the unit test is still fine. And it is not. And that's fine because... no, it's not fine. So what's going on here? 43. Oh, come on. 43. Missing. I don't understand what this test is doing. Alright. Alright, so the first one is actual, second one is expected. And what's expected here? Alright. Super hard to understand this test here. Wow, wow, wow. I think it didn't like the change I made here. Yeah, here we are. So what did we have here? It was if. Come on. Threshold.gauge. Is better. Okay. Still don't fully understand what went wrong here. I feel very incompetent. Very incompetent here. I certainly would say that this reporting of the results is very confusing. So metrics, these are mapping a store ID to a list of values. Alright, so oh, the second line is actually informing us what's going on here. So we are going to put this and then strings that replace all. All right. Oops. Cool. That's better. So what it's telling us is that on the one side, we have a value for gauge 0, and on the other side, we don't have one. So actual is with a value and missing is without. Cool. All right. Now we are talking. And so the error is on this line here. And what it's telling us is that there is a value for gauge 0 here, whereas we are only seeing... Yes, there we go. There we go. Now we are in the clear. And so we are going to continue to see the gauge here because it was not updated. And then we are going to remember it here as well. And then we are going to remember it here as well. And it's also going to tell us that the counters need to be updated. That's fine. So here we had counter 0 and counter 2. And then here we have counter 1 added as well. And that's fine. All right. Better. And then here we have counter... Oh, go 0 is 1. Oh yes, because the store 0 has not been affected. All right. So that means that at the end here we also have 1. And then it works. All right. Success. Success. All right. We've been working on this particular topic for 1 hour, and that means it is time for a legitimate break to move around and hydrate and be healthy. So we are going to reconvene at the hour, that is 3 minutes from now. Enjoy your break, everyone. And all right, we are back. All right, let's see what we need to commit or enter. So first of all, let's create a branch. I mean, this PR here has a branch, but it's actually we are actually working on a different area now. So probably we're going to overwrite the PR when this branch has become a bit better. So we continue with this. Then we have the health checker here that is absolutely going to continue here. So that is what we did earlier. It's fine. Recorder. Yep. Yep. And yep. All right. So that's that is better. Now we have our health checker. And so that has a recorder. Which we are going to come back in a while to. And then we had that logic, which we didn't like. Check health. Where was it? Status, node.go. Yeah, it's here. So that's the one we don't like, really. The write node status should not be the thing responsible for also getting the matrix health. And that's on the node. Node is a concept from KV, and the health check we want is actually relevant for SQL servers and SQL pods that don't have a KV node. So this entire idea of connecting the metric health to the node concept, which is not going to be available for a purely SQL server, is problematic, really. And so we absolutely need to extract this logic into something different. And it's okay. So we take our health check here, and we are going to do this. And that is stop. Run task, is that asynchronous? It is probably. Yep. And in here, we are going to have this sticker. And this is going to be configurable in some time. All right. And then we are going to report this now. Probably we're not going to start anything else. We might as well return the value here directly. And now we have a do health check. We are also going to report an error here. All right. And this is going to be there. Oh, welcome, Rochrail, and thank you for the follow. And so we are going to extract this logic here into here. But we are going to do this in a different way. So we need the node ID. Probably if we have one. Oh, node status is actually part of the check. Interesting. All right, so that is something I hadn't considered. What does it do? Come on. What does it do? We have node status.metrics. Stored status dot metrics. Oh, at 0. I see. All right, so it wants to get the metrics. I don't mind this. All right. Latest node metrics. String node 64. Latest store metrics map. pb.store ID, I think. Yep. And then map string float 64. And that's going to be under mu. Node.go. Recorder generate node status. Yes. Interesting. Generate node status. Metrics. Metrics. So in fact, we do like this generate node status being called as part of the health loop. So actually, that is good. And then we have this writing summary going somewhere else, and that is less good. So what I'm thinking about here is that we have here some piece of logic that is organizing writing the node status to disk at the very beginning when the server has just started, and then periodically at this frequency that's configured. And then it is alerting in Gossip. Oh, we are going, oh yeah, oh I like this. We are going to keep this here. Maybe, do we want that? We probably must exist. This must exist. It's right. Okay. It's because it needs to have the node status struct, but where the matrix come from doesn't really matter. They just need to be ready. Yeah, I like this. I like this. I like this. So we are going to collect those metrics using a method on the health checker. Latest metrics. Come on. Sync util. That's mutex. And we are going to have a status. And that contains the, okay. Cool. Cool, so this call here. Let's check reports. All right. We don't need this. And probably all right. So we take this. And is a node. And then here. And we are going to say h.latest.log. Cool. Cool. And this one is going to say node status. Oh, there is no error. No. So that is simple. Cool. No status is h.getLatest. All right. And then we have this logic here. And then here return nil probably. Right. And then there is a gossip thing. So it's going to be an alert TTL. And the alert TTL doesn't need to exist anymore. This goes away. And write no status will need to be thought about, say, pulse checker. And we're going to come back to this. Cool. All right. And where is this function called now? start write node status. Here. Cool. All right. So we inverted the control here. So before we had this function, start write node status, was run once at the beginning and then periodically at some metric related interval. And then the function was doing both getting the node status, writing the node status, and also performing alerts based on that information. And that is not the way it should be, because this loop here might stall. This write node status function is actually writing to KV. So imagine that the KV store isn't available. That makes this entire write status suspend, which is not necessarily a bad thing. It just says, well, it's suspending. It's just going to timeout, which is fine. But it does mean that our health reporting mechanism is partly broken. And so what we are doing instead is changing the control so that we are instead informing our health checker of the node status. And that means the health checker will have data to work with, even if the node status has not been updated. So we probably need something like, if it's not recent enough, we want to update it or something like this. But we're going to get to that in a second. So what is it complaining about now? Probably, I don't know why go imports is not working properly. But that's what it needs. Health check report, health check result. Yeah? Node.go. Here. Oops. So what does it need in this function? Initialize additional stores. I suppose. All right, so it's okay if it really wants me to not pass this argument, I will agree to this. It's okay. It's okay. All right. And now the node needs to be informed of things. All right, and where is the node constructed? Here. New node. All right, and where is the health checker? Created. Oh, we have a, okay. Node health checker. Then we will have a health checker. Yeah, we need both things side by side. Da-da-dum. And then we have a node health checker. Okay. And that is a node health checker. And that is going to be h.node. And that remains. And then we go. Alright, so we split the two checkers. This one is there. And then here. Then we have new node. Do we have a late bound node? How to make a store config. Oh my gosh, what is this? That is not properly defined, I fear. Cool. All right. Where is this broken now? Let's see. New node health checker with an H. This is not the right type. All right. Is it not? Am I not in the right place? Oh, node. This is not needed anymore because now it's embedded. And same. And that argument is not necessary anymore. Yay! All right. And so if we have a node status collected already enough. Cool. First time or too old? Oh. Actually, this condition works already. All right. All right. Report, see alerts. Okay, so we are going to store this. All right. Mm-hmm. See there. Return. No return needed. Cool. What am I missing here? Oh, I'm not in the for anymore. I suppose. Results. Select this. And then this. Alerts. Cool. That goes away. Off we go. Okay, cool. That is much better. Yep. What's going on here? Collect the node metrics. All right. In any case, latest clock. All right. We have achieved. We have achieved. So what did we achieve really? And that is the ability to collect the health information asynchronously without blocking on KV writes like we have here. False. I think. Maybe we do want that. Must exist. Cool. All right. The server. And write summaries right now. Cool. Well, this looks good. I do need a brief bathroom break again. And then we will wrap up the session for today by connecting the pieces together and verifying that it works. So let's meet again maybe in 2 to 3 minutes from now. And we are back online. All right. So our health checker now is storing the latest report in this field here. Let's verify these builds. And now we can expose it. Yeah, indeed. It's not used anymore. We can expose it via, for example, a debug interface. Cool. How would that look like? Maybe let's do the thing with health, because that's much easier to plumb around. And so there's a health response here. And do we have status PB things in this file here? Oh no, we don't. Oh, that is less optimal. All right, so we can do it with health. Well, too bad. Debug then. Debug it is. Server. And there will be a debug health, probably. Around here. Mm-hmm. Maybe say anything here. And then we are going to do h.log. All right. All right. I will come back to that in a minute. Right. I don't remember how someone says. I think. Yeah, maybe we want that earlier. Let's build this and try it out. How does HTTP work? Sounds... there. Oh, here we are. Cool. That seems to work. Let's start a server. All right. I don't remember if I'm able. Let's do this with insecure for now. Null. And then not null anymore. Off we go. All right. We have a health report that automatically updates periodically on a debug endpoint. We really would like to have it as part of the health endpoint. The health endpoint is not in the right package. We could move it to a different place. I wonder if any of these is interesting. This music by Wintergaten, Swedish engineer, music guy, one of my favorite numbers. Anyway, all right, so what's happening here is that we have our health reports, and I really would like to avoid having to type /debug/health. I really would like this to be on a public endpoint, but our public endpoint has a response type. Yeah, maybe that's... I wonder if the health response type is important. It's an empty type. It is an empty type. All right. status. Yeah, I fear a little bit that I can't. I won't be able to import this because of an import cycle. Would that be possible? Oh no, actually I might be able to do this. Let's see. So welcome, Just Naja, on the stream. Yeah, I might be able to do this. Oh, that sounds nice. Alright. Just give it health check results. And we need to have server status pb. Try this. Health check result is defined. What's the problem? Oh, this is the name. Looks better. Much better. Ah, nice. Nice. Right. Okay. Yeah, I'm forgetting a response here. Yep. Yep. Oh my gosh, I'm so happy. All right. We have feature. We have achieved. So there are two different health requests now defined, separate from each other. And else, this is a service endpoint specific to the web UI for a general endpoint suitable for monitoring use health. This endpoint does not require right. And now we are going to make a PR, well, a draft PR. At least we're going to make a commit message to initiate the discussion around this work. And we will probably need to add some documentation to the health code. All right. So, new health checker facility. The server now collects a health report period in the background and reports it alongside to as payload for HTTP get on health. All right. New background report. Notes. All right. So we need to explain a little bit what happened here, but we are going to say the following. Say health. Yeah, returns is now separate public from admin v1 health internal HTTP console. The health endpoint also now returns a report of the current health node. All right. What this work stems from a desire to inspect the state of subsystems inside CRDB as a concise, a CRDB node, so as to assess its general health. As a binary result previously provided by health was deemed insufficient. To achieve this batch extends the node alerts prototype feature from 2010. This feature uses thresholds on certain node metrics and generates gossip alerts visible to other nodes when thresholds are exceeded. Boost. The extension is to preserve the is twofold. The result of the node alerting code is now preserved in RAM outside of gossip, so it can be reported by health. All the interesting metrics tracked actually that are relevant for alerts are now values. Included in the health report, not just the alerts. They are reported even when their value is not in a danger zone. Health report has data, contains data, even if there is no problem detected. Alright. Actually, there's threefold. The abstraction is generalized from a system originally specialized to node metrics to ones that generally can assess the health of a server. To the benefit of this last point, the code that implemented the previous feature was extracted from the write node status logic, which is intimately so that it becomes less intimately linked to the ability to persist the node status proto in KV. This way the health checker can now update and maintain in RAM periodically updated the health report even when the node status range is not okay. No, maintain in RAM. A periodically update, I swear. To right, okay. Off we go! The latest measured health of the node, and that does remind me that we also absolutely need to indicate in the response when it was computed. And that is going to be a time. How do... 964. Collection time. We don't need that. And that is going to go here. Let's check. See health alerts computed. See health matrix current. There's related matrix. This node and indicators. It's the time at which this node was this health port was computed. A time too much in the past may indicate node malfunction, where the health checker itself is non-functional. Off we go. And I think there is generated document for this too. Yep. Why so many changes? Off we go. All right. So there is a public annotation here. I think. Let's see. Oh, it says reserved. Public. Yeah, there we go. Cool. This proceeds. Oh, I created my branch on top of another branch. Okay, so let's try again. And then reload this. Yeah. Off we go. No. Come on. There we go. And that is going to be supersedes. No, not this one. It's the other one. And we are going to create a draft PR. And I will look at reviewers in a later phase. That's the draft I said. Off we go. All right, so that is our result for today. Set 2 hours, and this is more or less the time that it cost us. We started 2 hours ago, and breaks not included. So yeah, and so we now only use the metric-based checkers that was already there for now, but the plan is to extend this. The plan before this merges is to extend the mechanism with SQL level checks availability of system tables, availability of authentication, availability of what else? Releases, job progress, etc. Maybe depending on interest and complexity. Cool. Here we are. Progress was made, and hopefully we will be better able to retrieve the health of clusters. So here it is. Thank you everyone for joining today. And by next week, the plan will be either to resume on the authentication work that we started last week, or maybe there will be progress on this one that we'll look into. In either case, it's going to be in this area, very likely. So that's that. Thank you for joining. Thank you for being there. And we will see each other again next week, Monday. Have a great afternoon or day.